Hi, I'm Gregory Shklovsky.
I'm Jesper de Jong, and this is Envision, a gesture interface device.
So right now for hand gesture interface development, you need to purchase some pretty expensive hardware to get started. For example, an Apple Vision Pro or a MetaQuest headset will run you at least $300 all the way up to $3,500. And even if you're programming gesture interfaces on those devices, you're bogged down by their closed off ecosystem, where you don't even have access to the AI models that perform the hand gesture recognition.
So we set out to create a better way to make hand gesture driven applications. So firstly, this started with an affordable hardware device that would have hardware accelerated gesture recognition on the device itself. So it would take in the camera input and process the gesture recognition on board. Secondly, we wanted to create a software development kit that would take the results of that processing on the hardware device and expose easy to use open APIs that developers could use on their own computers. And then lastly, we wanted to create a few demo apps to demonstrate the capabilities that this environment would bring.
So this is our system architecture diagram. The way our device works is that it first takes a picture of your hand in the physical world, and then it uses an onboard AI processor to extract the key points in the hand in 3D space, and then send that result over to any user device that has our software development kit running. On that device, the software development kit will translate those 3D key points into semantically meaningful gesture inputs to our computer, which we'll take in and process just like you would a keyboard input.
So these are some of our early prototypes. We started with an ESP32 as a baseline. And in order to implement what we wanted to on that, we were able to get most of it, but it couldn't handle our entire ML pipeline because the memory capabilities that it had were too low. So in our second prototype, we use a dedicated AI processor with the Hymax WiseEye2 AI MCU, and that gave us more capabilities and it gave us faster processing power with low voltage, but it had some compatibility issues with the opcodes that we were using in our machine learning pipeline.
This is our first prototype that we were finally able to run real-time gesture interaction with, connected to a physical PC that was running our software development kit. And this allowed a seamless interaction with our demo apps that we created.
And as you can see in the picture on the right, this was also an entirely self-contained prototype, meaning it was battery powered and would connect to your device over Bluetooth, so there was no need for physical connectivity in any way outside of what you see in the image. All right, so these are some of our demo applications that we use. The first one was this whiteboard that would track your index finger and map it to a location on your screen. But it did more than just track the location of that finger. It would also see what kind of gesture you're making and use that to use certain tools like changing the current brush color that you're using and clear the image as a whole.
The next demo app that we made was a desktop manager, and this allowed full control of your computer just using gestures. And you could use these to change your screen, go to a command center to pick out your current window, as well as even clicking on the screen. And this is pretty powerful because this worked on any device not being bogged down by a certain ecosystem.